Imagine supplying 1 million people with fresh, running water every single day inside a sprawling, ancient metropolis. Now, imagine doing it over 2,000 years ago. You have no electricity, no steel pipes, and absolutely no massive water pumps. Sounds entirely impossible, right? But welcome to ancient Rome, where gravity itself was harnessed as the ultimate cheat code for survival. By the 1st century AD, Rome was the undisputed center of the known world. It was glorious, monumental, and incredibly thirsty. A population of 1 million citizens required an astonishing amount of water for drinking, cooking, and their famous daily public baths. Without a massive, continuous water supply, this glorious capital wouldn't just be dry. It would become a stinking, disease-ridden nightmare. At first, the Tiber River was enough, but as the city exploded in size, the river became heavily polluted and completely undrinkable. You certainly wouldn't want to make your morning tea with it, let alone supply an entire empire's capital with that sludge. The emperor demanded a solution. He wanted pristine, crystal-clear water from the distant mountain springs brought directly into the city center. The task fell upon the Roman engineers. They were given an impossible deadline and a mandate that defied the laws of nature. Bring a flowing river down from the high peaks across miles of rugged valleys straight into the heart of Rome. And they had to do it using nothing but simple math, intense human sweat, and millions of heavy stone blocks. If they failed, the city would collapse into chaos. Or worse, the emperor might just feed them to the hungry lions. They couldn't push the water, they couldn't pull the water, they had to make the water want to move all by itself. This monumental challenge gave birth to the greatest engineering marvel of the ancient world, the legendary Roman aqueduct system. So how do you move millions of gallons of water across miles of uneven rocky terrain without a single electric pump? The answer is brilliantly simple. You cheat. You harness the ultimate free, non-stop engine of the entire universe. Pure gravity. The Roman aqueducts were not magical floating rivers. At their core, they were just very long, incredibly precise water slides. The engineers had to calculate a continuous, gentle downward slope, starting from the mountain source all the way into Rome. This was a terrifying balancing act. If the slope was too steep, the water would rush down with explosive force. High-speed water would smash into the stone walls, eroding the channels, and eventually destroying the entire aqueduct system entirely. But if the slope was too flat, the water would simply stop moving, stagnate, and become a disgusting mosquito breeding ground. So, what was the magic number? They aimed for a perfect drop of just 34 centimeters for every single kilometer. Think about that for a second. Over dozens of miles of rugged, unpredictable landscape, they maintained a nearly invisible slope. It is a level of precision that would make modern surveyors sweat, and the Romans did it without lasers or GPS. Instead, they relied on a tool called the corybates, a long, simple wooden bench with carved water channels to check ground levels. They also used the groma, a basic wooden cross hanging with weighted plumb lines to measure straight lines and right angles. Our poor Roman engineer had to stand out in the blazing sun, squinting at these wooden sticks for hours on end. He had to make sure the math was absolutely flawless, checking and rechecking every single inch of the massive construction route. Because if he messed up the calculation and the water stopped flowing, the emperor would probably just feed him to the lions. But even with the perfect slope, constant rushing water is incredibly destructive. Ordinary mortar would simply wash away. If the stone channels leaked, the aqueduct would fail. The Romans needed a super material to hold everything together. Enter their secret weapon, pozzolana, a magical volcanic sand that would change the course of architectural history. Sourced near Mount Vesuvius, this volcanic ash was mixed with lime and seawater to create Roman marine concrete. The engineers mixed it together in massive vats, And this wasn't just ordinary mud. This was a chemical miracle. Forget modern cement trucks. The Roman recipe was entirely done by hand, and it had a superpower. Unlike regular concrete that weakens in water, Roman marine concrete actually got stronger when fully submerged. The seawater triggered a chemical reaction with the volcanic ash, growing microscopic crystals that locked the material together like solid rock. Modern concrete breaks down and rusts its steel rebars in about 50 years. Roman concrete is still holding strong 2 millennia later. To make the aqueducts completely waterproof, engineers lined the inside of the stone channels with a special mortar called opus signinum. It was a mix of crushed terracotta tiles and lime. It created a surface so incredibly smooth, not a single drop of water could escape. With the super concrete holding everything together and the waterproof lining secured, the water was ready to flow. And flow it did. But the emperor didn't just want one aqueduct. He wanted them everywhere. Over centuries, they built an astonishing 50,000 miles of aqueduct networks spanning across Europe, North Africa, and the Middle East. That is long enough to wrap around the entire Earth twice. Our poor engineer is going to need a lot of overtime. Getting the slope right was one thing, but Mother Nature didn't exactly provide a flat, easy carpet for the Romans. When a massive mountain stood in the way, going around it would ruin the perfect slope. So, the emperor ordered them to go straight through. They didn't have dynamite. They had to carve miles of tunnels through solid bedrock by hand, using simple pickaxes and sheer willpower. To keep the workers from suffocating in the dark, they dug vertical shafts from the top of the mountain all the way down to the tunnel. These shafts acted like chimneys, letting out the thick smoke from their oil lamps and letting in fresh air so they wouldn't pass out. But carving through mountains was only half the problem. What happens when your perfect downward slope hits a massive plunging valley? If you just let the water drop down the valley wall, the sheer speed and immense water pressure would literally blow the stone channel apart. So, to cross deep valleys without losing their precious water, Roman engineers used a brilliant physics trick: the inverted siphon. They forced the water into closed pipes, dropping it sharply down into the valley, creating a massive U-shaped system. The immense pressure built up at the bottom naturally pushed the water right back up the opposite side of the valley. Genius, right? To pull this off, they couldn't just use stone. They had to forge massive, heavy pipes out of pure lead, known as fistulae. However, there was a major catch. The water pressure at the very bottom of these U-shaped siphons was absolutely terrifying. If the lead pipes were even slightly weak, or if the soldering wasn't entirely perfect under that immense weight, boom! You would get an explosive, ancient geyser wiping out the system and leaving you with a very, very wet engineer. Because these siphons were dangerous and insanely expensive to maintain, the Romans usually preferred a much more dramatic, show-off solution. Building a massive, solid stone bridge across a deep valley was incredibly expensive and required millions of heavy stone blocks. But the emperors of Rome did not just want functional plumbing. They wanted a permanent monument to their absolute power. A solid, boring wall blocking a valley was ugly. The emperor demanded something beautiful, something that screamed Roman dominance. This led to the widespread use of the architectural marvel that defined the entire empire: the iconic Roman arch. The arch is a stroke of structural genius. The curved design takes the massive downward weight of the stone blocks and perfectly distributes that crushing pressure outward and down the curve, straight into the thick vertical support pillars. This meant the Romans could build incredibly high structures using much less material than a solid wall, while remaining incredibly strong. And if one arch was impressively strong, stacking them on top of each other was even better. Take the magnificent Pont du Gard in France, for example. It features 3 tiers of arches rising 49 meters into the sky. These towering structures weren't just carrying drinking water. They were massive, unmissable billboards of Roman superiority. Imagine being a local barbarian tribesman, living in a simple wooden hut, and seeing this colossal stone giant crossing your sky. It sent a crystal-clear message. The Roman Empire is here. We are infinitely powerful, and we can conquer nature itself. At the very top of these towering arches sat the Specus, an enclosed water channel keeping the water clean and safe from the blazing sun. The water glided perfectly across the valley, maintaining that precious, microscopic mathematical slope we talked about earlier. Through dark tunnels, down deep siphons, and over majestic arches, the fresh mountain river finally arrived at the gates of Rome. The water had finally arrived. But it didn't just flow randomly into the streets for everyone to share equally. It flowed into a massive distribution tank called the Castellum Aquae, where it was carefully divided into three main pipes. The lowest pipe, which always got water first, went straight to the emperor's palaces and the private villas of the wealthy elite. The middle pipe went to the public bathhouses, which were the absolute social heartbeat of daily Roman life. And finally, the highest pipe, which only received water when the tank was completely full, went to the street fountains. This is where the regular citizens, slaves, and the poor had to line up every day just to fill their household jugs. It was a strict social hierarchy built entirely on physics. The rich got their water first, absolutely guaranteed. Even during a severe summer drought, the emperor's private ornamental pools would remain full and completely luxurious, while the public fountains in the plebeian neighborhoods would be the very first to run completely dry. These official pipes were strictly regulated and stamped with the owner's name, allowing inspectors to track exactly who paid the water tax. But of course, in a bustling metropolis of 1 million people, not everyone wanted to pay the government's hefty utility bills. This created a massive underground industry of illegal water tapping called puncturing. Regular Romans would sneak out at night, punch secret holes in the main pipelines, and steal the emperor's water right from under his nose. With thousands of illegal punctures across the city, the emperor's massive water network was bleeding out, leaving public baths completely dry. To stop this ancient water mafia, the emperor appointed a no-nonsense official named Sextus Julius Frontinus as the water commissioner. Frontinus launched a massive investigation, hunting down corrupt officials and wealthy elites who bribed guards for free water. He smashed the illegal pipes, heavily fined the thieves, and finally restored the rightful flow of water to the people. But human thieves were only part of the problem. The aqueducts faced a much more relentless, invisible enemy: limescale. Because the fresh mountain spring water was incredibly rich in minerals, a rock-hard layer of calcium carbonate constantly built up inside the channels. If left entirely unchecked, this white crust would completely choke the pipes, reducing a raging river to a pathetic trickle. This meant the entire 50,000-mile network required a massive, permanent army of maintenance workers known as the aquarii. These poor laborers had to regularly squeeze through narrow, vertical maintenance shafts, descending deep into pitch-black tunnels. Armed with nothing but simple iron chisels and small oil lamps, they spent hours in cramped, claustrophobic spaces, chipping away the hardened calcium. It was a miserable, terrifying job. One wrong move, or a sudden, unexpected surge of water, and you could be swept away in the dark. To repair damaged sections without cutting off the entire city's water supply, engineers built clever bypass channels, temporarily diverting the flow. They also constructed massive settling tanks along the route, forcing heavy dirt and debris to sink to the bottom so workers could easily shovel it out. Thanks to this non-stop, grueling maintenance, the water arriving in Rome remained incredibly pure and perfectly clear for centuries. Frontinus was so proud of his immaculate system, he famously scoffed and asked, "Will anybody compare these monumental aqueducts with the idol pyramids?" For centuries, these spectacular aqueducts were the literal lifeblood of Rome, fueling its unstoppable expansion across the known world. But no empire lasts forever. By the 6th century, the once invincible Rome was crumbling, weak, and highly vulnerable. In the year 537 AD, a massive army of Ostrogoths arrived at the gates, ready to lay siege to the Eternal City. They quickly realized that breaking through the colossal Roman defensive walls would be nearly impossible. But they didn't have to. To defeat Rome, they just needed to make it thirsty. The barbarians systematically smashed the exposed aqueducts outside the city. For the first time in nearly 1,000 years, the great artificial rivers of Rome simply stopped flowing. Inside the walls, panic set in. The massive bathhouses ran bone dry, the public fountains sputtered and completely died. Without clean water, diseases spread rapidly. The city's population plummeted from over 1 million to barely 30,000. Rome was abandoned, falling into the Dark Ages. But while the empire totally collapsed, their concrete and stone did not. Even today, 2,000 years later, the massive skeletons of these majestic aqueducts still march across the European landscape. Amazingly, some of them, like the Aqua Virgo, are actually still functioning and supplying water to Rome's famous fountains right now. So, while our modern steel pipes rust and our expensive electric pumps constantly break down, the Roman engineers left behind an eternal monument to sheer human stubbornness, brilliant math, and perfect physics. They proved that you don't need magic or future technology to achieve the absolute impossible.